Students, today we will study about baking. Baking is, as you know, is a quite complex process which involves a variety of physicochemical changes as well as a variety of treatment that involves basically all modes of heat, that is radiation, convection and conduction as stated, and there is also a mass transfer happening, that is the water vapor and the air movement that is going into the oven in which you are baking, either it's microwave or it's the wood fired oven, anything. Then since the baking is quite a complex process, and as you know, you can't change anything during the course of baking. Once it's into the oven, there is no possibility of changing anything. So there are a variety of undesirable transformation that happens into the baking process. That may be the excessive browning, pigment, vitamin degradation, fat oxidation, rancidity, as well as decrease of nutritional quality by reversible or irreversible changes of protein. So these are the things that needs to be standardized, or you can say needs to be checked before you bake anything or before you move on in course of baking. Then there are a variety of parameters that you decide or you choose as upon in the course of baking. Say the magnitude of various reaction will depend on the history of time dependency of temperature, moisture content, and other variables such as pH, water activity. As you all know that our baking process all starts with the course of art, which predates our history, and we have learned from that place itself. Now since if you have baked anything, you might be knowing that baking is quite a time dependency on the basis of temperature. The more the temperature it is, the more the browning it happens and lesser the time it takes. But more lesser the temperature it is, the more time it takes, but the might firmer the product will be. But you can't go beyond a certain limit of a temperature range, not less or no more. Also, there needs to be an optimal moisture content, else if there is no optimal moisture content, your product might degrade or you might retain moisture even after the baking has happened. Now the other variable that includes pH and water activity. Water activity, as you know, is just the availability of water for chemical changes and biological activity to happen. So you need to control it, since baked product has relatively a high shelf life. Also in case of pH, especially the food uses baking powder and soda, which only activates in course of a certain specific pH. That is a very important parameter to note. So optimal pH also needs to be maintained to have the baking powder activated. Next, there is a various changes. Say product are categorized as to as macroscopic phase with discontinuities, means you have two phases that you can observe but they are not continuous in nature. As a result, there is an elevation. Also, the final gluten 80% of protein will denaturate at 72 to 86 degrees centigrade. A significant volume expansion, as you can see in bread loaf, there is a 2 to 5 times of rise due to the production of CO2, and also the added because of the added leavening agent and the moisture that is leaving during the course of baking. Now we'll see, this is the general scenario for the chemical reaction that occur into the baking process, in which you use sodium bicarbonate, which basically releases sodium and HCO3, that is bicarbonate salt, and that carbonate then reacts with the water molecule, or basically the ions that is generated from the acid, which breaks down and it converts to CO2 and H2O. Okay, now there is another category of leavening agent that you see in bread making, which basically uses yeast fermentation, in which you use which you use alcohol and a fermenting agent which eventually produces lactic acid to give it specific taste or the required acidity if you are still adding any leavening agent such as baking soda or powder. Next, we'll move on to a specific diagram in the page number 6. In this, you can see a basic way of baking as how baking is performed in a certain scenario. Like say imagine if the two slab is the baking portion. Here you can see that they are all three ways that is converging the heat. Say the conduction by the direct plate surface, that the physical plate surface you can see, in which you see that the heat is conducted through the plate from the bottom part itself. Then there is a convection occurring in between the air surface as through the heat is transferred, that is heated from the plate, and it is convective, transferring it heat to the product. And again there is a radiation, as you know that the bake or the baking machine used is quite radiant in nature, like it glows red, and eventually a red part generally emit heat, as you all know, so that also contributes to the radiation cooking of the whole product. Now, radiation, in case of radiation, you know radiation is a radiant heat that doesn't involve any media to transfer, and most of the studies have shown that almost 50 to 80% of the total heat transfer that is governing the whole baking process is through the radiation itself. As you know, radiation is an electromagnetic wave. All the body emits electromagnetic wavelength between 0 and infinity, right? 0 means nothing and 1 means maximum emissivity that is given to a pure black body. Then the radiant energy travel uninterpreted until it strikes a surface where it is either absorbed, reflected, or transmitted. So in this course, in case of absorption, the product that you are baking will absorb the basic thing. In case of reflected, the crust part after the baking has happened, it might reflect most of the part, that is most of the radiant heat that is actually incident onto the bread surface. And transmitted is when it's transluted, or when it's partially baked, it will transfer the radiant heat into the whole product. Now next, you all know the radiant heat calculation, as this is the basic calculation for radiant heat transfer. It is QR is equal to sigma AT4. Sigma is the Stephen Boltzmann constant, and A is the area of the oven, or in specific, if you want to calculate the amount of energy absorbed by a certain product, it will be the area of the surface of the product that is actually incident to the radiant heat, and T is the temperature difference between the starting and the ending of the baking process. In this you have an addition of epsilon, which basically states the emissivity that ranges from 0 to 1. It depends, and it is like for most of the food, emissivity is equal to the absorptivity, that how much it is emissing, it will absorb the same amount as in between. Then the net heat transfer for radiation is determined by epsilon sigma A T14 minus T24. You all have studied this part in your thermal conduction chapter. That is the same part, nothing there is no much difference in this. Then we'll move on to the convection part. Convection also you have studied in the basic heat transfer operation chapter. As you know, convection is the basic molecule movement that transfers heat from one place to the another. Room heating by radiator or above top heater of the water are the basic example of convective heat transfer, right? You all have used a rod into your product that also contributes to the heating through the help of induction. That induction is nothing but just the convection heat transfer, which convects the heat from one molecule to the or the molecule. And the basic formula for this, as you all know, is Q is equal to HA delta S minus T, that is the delta T. QCV is the heat by convection, H is the heat transfer coefficient, Ts is the product surface temperature, and T is the temperature of the bulk fluid. Since convection happens only in a fluid part, we don't consider convection in a solid matrix. So in case of baking, you won't have a convection throughout the whole course of baking. At the course of cake making, say, in which the batter is in a fluid matter, they till everything is solidified and the starch is gelatinized and the protein has denaturated and it has attained a specific, you can say, a specific structure after the baking has been completed. Till that part, you will have the convection happening at that place. Else, after everything has formed a structure and everything has attained a specific shape, there will be no convection except the air that will be traveling through the holes created due to the carbon dioxide emission and the water vapor, right? Now next is the conduction. Next is the conduction part. In case of conduction, you all know that conduction basically happens to transfer heat through a solid part. There is nothing much difference, it's just the part that gets transferred through the bottom of the surface. Now in case of convection, as since convection is quite complicated process to calculate, and you can't actually observe, since the shape of the bread or shape of any food product that you bake doesn't have a specific shape that can be correlated easily to any of a solid shape available. So there are various numbers with which help you can calculate various parameter. The first is Nusselt number. As you know, it shows the relation between the convective and the conductive heat transfer with respect to the characteristic dimension. And the Prandtl number, as you know, the Prandtl number shows the specific heat relation with the viscosity and the conductive heat. Means the amount of viscosity provided, or the viscosity of a fluid is inversely proportional, or you can say it's directly proportional to the amount of conductive heat that it will transfer. Then next is the Grashof number. It actually shows the relation between the surface characteristic and the viscosity, that what is the area, what is the density of it, and what is the temperature difference that it is subjecting to with respect to the viscosity. The more the viscosity it is, the lesser the Grashof number becomes. All these numbers help to eventually find the convective heat transfer for a particular surface. Now there is another is the Nusselt number. Nusselt number, for after the calculation of all the numbers, you can have a Nusselt number as shown as Nusselt number is equal to 0.664 Reynolds to the power 1 by 2 and Prandtl to the power 1 by 3. You have studied this part in heat exchanger, where the formula was 0.8 multiplied by Reynolds number to the power 0.4 multiplied by Prandtl number to the power 0.6. The same formula with our respective shape factor have changed the formula to 0.66 for Reynolds to the power 1 by 2 and Prandtl to the power 1 by 3. Now next is the equivalent diameter. In case of Reynolds number form calculation, or even in case of Nusselt number formulation, as you can see in above, you have HL by K. This L is basically what the characteristic dimension or the equivalent diameter, sometimes stated, is basically what the relation between the height and the breadth of either the baking chamber, or you can say either the baking chamber or mainly the product that is using. Next, we'll see the production with the help of Grashof. Then